Hey guys, so we are doing the last topic from the chapter D, which is basically remainder theorem. Now let's see what this is all about. So what we have is we have a few statements with us which we need to analyze. So the statements are x when divided by 4 leaves a remainder of 2, y when divided by 4 leaves a remainder of 1. And then there are four questions. For example, x plus y divided by 4, we have to find the remainder. X minus y divided by 4, we have to find the remainder. And x into y divided by 4, we have to find the remainder. And y minus x divided by 4, we have to find the remainder. Now what happens is that for this entire topic, there is just one single theme that you are going to remember, even for question solving, even for now, which is going to make your life a much simpler. Now the theme or the statement, the only one statement that you are going to remember and apply throughout this remainder theorem idea is that replace the number by remainder. Listen to this very carefully. You are going to do replace the number by remainder straight away. Simple as that. For example, if I apply that, the first statement, x when divided by 4 leaves a remainder of 2. My number is x. I just said that we need to replace the number by remainder. So I'm going to replace x by 2. Similarly, y when divided by 4 leaves a remainder of 1. I'm going to replace y by 1. That's it. That is the only thing that you are going to do. And let's see what happens then very quickly. So the first question, x plus y divided by 4, याने for us x is 2, y is 1, x plus y becomes 2 plus 1, 2 plus 1 becomes 3, 3 when you divide by 4, I hope you will realize that you can't divide, you will get the remainder as 3 itself. Similarly, second question, x minus y, याने 2 minus 1 is 1, 1 when divided by 4 will give you the remainder as 1 itself. Third one, x into y, which is 2 into 1, which is 2. 2 when divided by 4 will give you the remainder as 2 itself. And the fourth one, y minus x, which is 1 minus 2, which is minus 1, which is divided by 4, will give you the remainder as minus 1. Now I know you must be a little bit surprised that what is this negative remainder and all of that. Don't be afraid right now. We are soon going to understand what that exactly means also, but so far right now based on the valuation, just take it like that. Minus 1 when divided by 4, you get the remainder as minus 1 itself. So the central theme of this topic is, this is the one, replace the number by remainder. Exact same thing you are going to use in the questions as well. And now going back to the same query, which is the idea of negative remainder. So let's explore that in detail. So what we have is, on the number line, we have written some numbers 4, 5, 6, 7, 8, 9, and all the numbers, because we were dividing by 4 in the questions that we were discussing right now. Let's try and represent all these numbers as a multiple of 4. And what we will do is we'll go from left to right as well as right to left. So when we go like that from left to right, what we have is 4 is some multiple of 4, which is 4k. 5 can be written as multiple of 4 plus 1, yani 4k plus 1. 6 can be written as multiple of 4 plus 2, yani 4k plus 2. 7 can be written as multiple of 4 plus 3, yani 4k plus 3. And 8 is a altogether different multiple of 4. Going behind from right to left, we have 8 as another multiple of 4, which is 4m apparently. 7, if we are wanting to write in terms of 8, we get multiple of 4 minus 1, yani 4m minus 1. 6 we get it as 4m minus 2. 5 we get it as 4m minus 3. And 4 we get it as 4k as a multiple of 4 itself. Now what happens is, suppose if I pick one number out of these, suppose if I pick 7, but for that 7 number, I have two generic forms available. One of them is multiple of 4 plus 3 and one of them is multiple of 4 minus 1. So if I consider 4k plus 3 and if I divide that by 4, obviously I'll be getting the remainder as positive 3. But if I pick the another form for the same number, which is multiple of 4 minus 1. And if I divide that number by 4, 4m minus 1 divided by 4, what I'll get is remainder as minus 1. So I think it becomes very, very evident and clear from this particular scenario is that negative number is nothing new as such. It is just another way of representing positive remainder only. And for every positive remainder, there is going to be an equivalent negative remainder. For example, another example, if we pick 6, one of the generic types, if we divide by 4, we will get the remainder as plus 2. And the other type will get the remainder as minus 2. For 5, one of the generic type when divided by 4 will give us the remainder as plus 1, and the other generic type will give us the remainder as minus 3. So both positive and negative remainders are part of each other. They are related to each other. It is nothing new, nothing fancy as such. You don't have to be scared at all going forward for this. All you are going to do is if you get a negative remainder, try and figure out the positive remainder, the equivalent positive remainder. So that's the idea of negative remainders. Now, whatever the theory that we have learned, let's try and apply that in terms of solving the questions on remainder theorem. So this is a question that we have: x when divided by 15 leaves a remainder of 2. And as usual, if you remember the central idea, replace the number by remainder. So we are going to replace x by 2, straight as that. And then we have 4 questions as usual. First question, x square when divided by 15. Yani x square becomes 2 square is 4. 4 when divided by 15 gives you remainder as plus 4. Next is x cube, which is 2 cube when divided by 15 will give you the remainder as 8. Next is 2 raised to 4, which is 16. 16 when divided by 15 will give you the remainder as plus 1. And the fourth one is the type of questions mostly that you will see, which is x raised to 86. In this case, it will become 2 raised to 86. So 2 raised to 86 divided by 15, what is the remainder? And this is where it becomes interesting, because now going forward, what we are going to do is, again listen to this very carefully, is that which power of the given number which when divided by the given divisor will give you the remainder either as positive 1 or negative 1. In simpler words, in this particular question, we are going to figure out which power of 2 when divided by 15 will give us the remainder either plus 1 or minus 1. Both will work. And if you observe, just now in the third question we had seen that x raised to 4 yani 2 raised to 4 divided by 15 gave us the remainder as positive 1. And that is why what we are doing is also that this 86 we are trying to split it as multiple of 4. So obviously 86 is not a multiple of 4. The nearest number to that which is multiple of 4 is 84. And that is why the adjustment that you can see. So 2 raised to 86 can be further written as 2 raised to 4 the whole raised to 21, because then it becomes 2 raised to 84 into 2 raised to 2. Laws of indices from the topic surds and indices, which is D1. The whole thing divided by 15. Now, when we start dividing, obviously 2 raised to 4 is 16. 16 when divided by 15 gives us remainder plus 1. And the right side is 2 raised to 2, which is 4 divided by 15 will give us the remainder 4 only. And if you remember the idea again, replace the number by remainder. We'll replace 16 by 17. And then my question becomes 1 raised to 21 divided by 15. 1 raised to anything becomes 1. 1 divided by 15 gives me a remainder plus 1 only on the left side. On the right side, I have 4. 4 when divided by 15 gives me a remainder as 4 itself. Beach mein we have multiplication 1 into 4. We get the answer as 4 as the final remainder. So this is how the simplification will work. The only thing that you are going to require is which power of given number when divided by the given divisor will give you the remainder either as plus 1 or minus 1. That's the only thing you are going to figure it out, and then after that you need to do the mathematical simplification. The next one after this is another question where in which we have x when divided by 80 leaves a remainder of 77. Now I know that we need to replace the number by remainder, but we can't replace x by 77. That will be too tedious to handle because 77 square, cube, raised to 4 and all of that will be a mess. But instead here what you should ideally do is you can use the idea of negative remainder. So divided by 80, you get a remainder of positive remainder of 77. Obviously, you will also get a negative remainder of minus 3. And that is also a remainder, whether it is 77 or minus 3, irrelevant. And now because of this important idea, what else that you can do is instead of replacing x by 77, which is huge for us for simplification, we can replace x by minus 3, which is also the remainder. So remember folks, whenever the positive remainder is very huge, think of a negative remainder which will be equally less, which will be easy for you to handle the calculation. So x becomes minus 3, all the questions will change straight away. X square यानी minus 3 का square is 9. 9 when divided by 80 gives you the remainder as 9 itself. X cube यानी minus 3 का cube is minus 27, which when divided by 80 will give you the remainder as minus 27 or positive 53. How do we get that? 80 minus 27 gives us positive 53. X raised to 4 minus 3 raised to 4 is positive 81. 81 divided by 80, we get the remainder as plus 1. Fourth one, x raised to 86 as usual, minus 3 raised to 86. Same idea, which power of minus 3 when divided by 80 will give us the remainder as plus 1 or minus 1. And again, just now we had seen in the third question that minus 3 ka fourth power when divided by 80 gives us the remainder as plus 1. So same thing we are also going to apply here as well. Minus 3 ka fourth power divided by 80 will give us the remainder plus 1. But here 86 again is not a multiple of 4. The nearest number is again 84, and hence the adjustments, laws of indices. So minus 3 raised to 86 can be further simplified as minus 3 raised to 4 the whole raised to 21 into minus 3 ka square divided by 80. As usual, minus 3 raised to 4 is 81. 81 divided by 80, you get the remainder as 1. Minus 3 ka square on the right side is 9. Positive 9 divided by 80 will give you remainder 9. As usual, same idea, replace the number by remainder. So 81 के जगह पे we are going to replace 1. 1 raised to anything becomes 1. 1 divided by 80 gives you remainder 1 only. Right side में you get the remainder 9. In between there is a multiplication. 1 into 9, you get the answer as 9. The final answer as 9. So once you understand which power will give you the remainder plus 1 or minus 1, you easily can simplify the type of questions, no matter how complicated they seem to be. So these are the workings that are necessary to tackle this topic. Now one last part before we wrap this up is finding the remainders for non-coprime numbers, as in 5 when divided by 3 you get remainder 2, 50 when divided by 30 you get remainder 20, 5000 divided by 3000 you get the remainder as 2000. So combining all these three conclusions, what we can say that in a generic form is that a upon b, I mean if you divide a by b you get the remainder as r. So if you do ax upon bx, obviously the remainder will be rx. The same multiplying factor with which you are multiplying the original numbers a and b, the same multiplying factor will be used to figure out the remainder, r के जगह पे rx. Folks, that's it for today from the remainder theorem topic, and with that we also conclude the D module. So C and D are number system. Do revise them, do go through them. If you still have any queries, concerns, do let us know. Thank you so much.